Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present my bachelor degree project 2. The title is A Study of Strength on Joint by Clinching Process. And my name is Muhammad Nur Hafiz bin Hishamuddin. My student ID is B09181041. And my supervisor is Encik Hamzah bin Muhammad Dom. This slide shows the table of content for this PowerPoint slide. First, we have chapter 1, which is introduction, problem statement, objective and scope. Second, we have chapter 2, which is literature review. Chapter 3, which is methodology. And chapter 4, which is result and discussion. There is also chapter 5, which is conclusion and recommendation. Next is about clinching. What is clinching? Clinching is also known as a press joining, a bulk sheet metal forming technique that is used to connect thin metal sheets together without the need of any extra component. Special tools are used to plastically create an interlock between two or more sheets during the clinching process. And why clinching is used in industry? Clinching is used in industry because this technique is frequently utilized since it does not need a large amount of time and it is more cost efficient than other sheet method. Next is problem statement. In mechanical clinching process, there are several diminished punches and dies are installed inside a die set at specific posture to clinch metallic sheet pieces unitedly in one stroke. Due to the complexity in setting the alignment for many punches and dies inside a die set, a minor irregularity due to the displacement between the center axis of higher punch and lower die. Tooling misalignment is typically caused by the following: inaccurate fabrication of component and distortion due to power exerted and vibration after age of services. The objective of the study is to investigate the variance of tool misalignment in mechanical clinching by measuring joint strength in different offset situation for clinching tool and defining an acceptable allowance. Second, to improve knowledge of the mechanical action of the clinch joint, where the quality of joint strength can be referred to aid in proper tool alignment setup. Lastly, to design a simple simulation by implementing the parameters selected to obtain a different result. The scope of the study is to observe the strength difference after clinch tool is offset to a specific amount, to measure a multiple result, and lastly to export the result of simulation to obtain a clear information. Next slide show the literature review. We have 3 theory on literature review. The first one is mechanical joint assembly, second one is clinch joint strength, and the third one is consistency guarantee of clinch joint. This show the mechanical joint assembly. The first one is clinching. The experimental analysis of forming and strength of clinch riveting sheet metal joint made of different material by Kasha in 2013. There are 4 phases of clinching. Next one is welding. The literature review tells about the type of welding application, advantage and disadvantage. This is also show the fabrication of 2 or more parts. For the next part of mechanical joint assembly is self-piercing riveting. Mechanical joining of fiber reinforced polymer composite to metals is the literature review for self-piercing riveting. Self-piercing riveting is a high-speed mechanical joining device which no need to pre-drill the holes, and the picture in the slide show the cross-section of face loop for the self-piercing riveting. Lastly, we have the comparison of metal joint process. This is the table for comparison of metal joint process. This is to ensure the integrity of the clinching process by Varis in 2016. Next literature review, we have the clinch joint strength, which consists of 2 items. The first one is the properties. The literature review is the analysis of lock forming mechanism in the clinching joint by Mucha in 2011. This tell about the button separation and neck fracture. Next one, we have the geometry of tools. The literature review is joining of high strength steel and aluminium alloy sheet by mechanical clinching with dies for control of metal flow. by Abe in 2012. This literature review influenced material flow of sheet metal, especially at neck thickness and interlock. This slide show the three most important item in consistency guarantee of clinch joint. The first one, the literature review title is Effect of Friction Models on Stress Distribution of Sheet Material During V-Bending Process by Ramazani in 2009. The next one is Destructive Test, which is to testing the and inspecting the welds by Stramel in 2019. It is a link metal sheet, will be tensile and fatigue test. Next one is non-destructive test. The quality inspection of clinch joint and steel and aluminium by Zhongxia in 2014. The tolerance gauge in the slideshow is torque airlock and lance airlock. Slide show the 6 methodology for chapter 3. The first one is process flow chart. Next is experiment setup. Next is process clinching. After that is cross section analysis. Next, loading test, and finally the FEM model offset. The process flow chart. First one we will start the process and then distinguish the problem. Then we have to do the literature review. Then material selection or clinch offsetting, sample preparation, and then we have to do the testing. If the testing is good, we have to proceed with result analysis and report writing. This slide show the experiment setup. The first picture show the punch and die for the clinch machine. The second picture portrays about the offset, which the first one A is no offset, second one B with 0.25 mm, C with 0.50 mm, and D with 0.75 mm. The last picture show the clinch process that we will do in the chapter 4. Next slide show the process clinching. The first one we will carry out with the help of the Instron 5582 universal testing machine and the equipment as shown in the picture. But there will be a slight problem, and I will tell you on the chapter 4. Next is cross-section analysis. There are two different sheets of material, which is aluminium and steel. But after doing the process, I conclude that we will just use one, which is aluminium. The cross-section joint will not be examined by using the experiment face-to-face, and the punch stroke is changed. The slide show the loading test for the process, and there are two types of loading tests, which is test opening test and tension sharing test, and there are two conditions, which is offset and non-offset. The Shimadzu Servoplus E50 dynamic testing machine will be used, but for some problem we will not doing the face-to-face machine testing. And next we have FEM model offset. The picture show the study of the development of interlock and the axis symmetry and plane strain model. Lastly, we have 2D rigid plastic FEM model of mechanical clinching by a study of cardiac in 2017. This slide show the three subtopic in chapter 4, which is offsetting, static test, and summary result. This table show the offsetting clinching condition. Clinching experiment simulation were carried out in a variety of offset orientation in order to investigate the effect of tool distortion on the forming load during clinching. The fact that there is no significant variance in forming load when the tool offset is modified is worth nothing. As a consequence, it is difficult to detect tool eccentricity during press operation by screening and monitoring. In the table, there is in-plane offset direction, which is theta. They have four varieties, which is 0 degree, 90 degree, 180 degree, and 270 degree. And the offset ratio, delta E, which is 0%, which is without offset, 25%, 50%, and 75%. And the die clearance of 1 mm. There is no lubricant used in this cold forming simulation. This slide shows the offset for the three kind of offset. The first one is 0.25 mm offset, second one is 0.5 mm offset, and the third one is 0.5 mm offset. This is all a SolidWorks design. The SolidWorks design, SolidWorks design should be used in Qform software to run simulation. Unfortunately, because of lack of experience and knowledge about the software, the simulation cannot be run and the analysis cannot be done, and there are no data can be observed from this offset condition on clean joint process. So for the subchapter 4.1, which is offsetting, the study was counted as failed to be observed because there is no data on the analysis that can be observed. This slide shows the static test. When performing the joint static test, it is possible to detect two distinct type of failure called named as button separation and neck fracture. There is two type of static test will be used, which is opening test and tension sharing test. By static test, we have opening test. The opening test was done the simulation and analysis in SolidWorks, and by using the maximum force of 60 Newton. We have three data analysis, which is the first one is stress with the maximum of 5.359 exponent 6 Newton meter square, and the lowest point is 5.440 exponent 4 Newton meter square, and the strain with the highest data is 5.605 exponent 5, and the lowest data for strain is 1.014 exponent 6, and the last one we have displacement. The highest data for displacement is 2.585 exponent negative 2 mm, and the lowest is 1.000 exponent negative 30 mm. For the next slide is tension sharing test. The first one, which is stress. The highest point of stress gain is 4.017 exponent 6 Newton meter square, and the lowest is 3.543 exponent 00 Newton meter square. Next is the strain. The maximum strain is 4.231 exponent negative 5, and the minimum is 3.043 exponent 11. And last one is displacement, which is we get the highest point is 4.418 exponent negative 3 mm, and the lowest is 1.000 exponent negative 30 mm. These two tests, which is opening test and tension sharing test, were using aluminium alloy 1060 in the simulation. For the last subtopic in chapter 4 is summary of result. This chapter is will discuss about the result, simulation, and analysis of this project. Firstly, according to the methodology in chapter 3, this project should be done by using lab and real machine for clinching. But unfortunately, UTEM has no clinching machine, and due to the COVID-19 cases in Malaysia, almost every factory that I go to ask for permission to use clinch process does not accept outsider to use the machine. The next idea is to gain data by using simulation. At first, using SolidWorks to do the product design is a bit easier because SolidWorks is a software that I already know how to use. But when I want to do the simulation and analysis in Qform, it will become a very problem because I had never experienced using Qform, and I already asked for another lecturer about this, and my supervisor also doesn't know how to use Qform. But there is three data that can be observed from the analysis, which is stress, strain, and displacement by using opening test and tension sharing test. For the last slide, which is conclusion and recommendation, first we have the conclusion. It is the objective of this research to intentionally misalign the alignment of the punch and die in order to investigate the impact of tool misalignment in mechanical clinching in the strength of the clinch joint. But unfortunately, the objective does not meet the solution here because the Qform simulation for this project was counted as failed. But for the analysis in the opening test and tension sharing test were carried out nicely, and we get the data for the stress, strain, and for the displacement. Next, for the recommendation, the fact that the misalignment cannot be researched in this study, but the study of the opening test and the tension sharing test were done perfectly. But I hope that this study can be researched more than what I have done, and furthermore, the future research should be conducted in laboratory so that it can provide a better and accurate result for explanation for the acceptable and occurrence of neck fracture failure. So that's all from me. Thank you.